Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how you can factor trinomials. Now, we're going to talk about a lot of different ways that you can factor trinomials. The ones that we're looking at are going to be in the form of x squared plus bx plus c to start. Now, I consider these ones to be simple. Now, there's lots of different ways that you can factor trinomials, but one way that we are going to talk about is something called the X games. So the X games ends up talking about how we use factors of what we want to multiply to in order to add. So when we're factoring these trinomials, ultimately our goal is to end up getting something like this. So because when we multiply, these two numbers have to multiply together, whatever we multiply to is going to end up being this c, because those typically end up being our constant terms. Then our first two numbers that we're going to fill in here are going to be whatever this number is, the square root of it, or some numbers that multiply to get us that. So for these basic questions, we're going to end up having an x and an x. If it was a 2x, we would have a 2x, or 2x squared, we'd end up with a 2x in one place and an x in another. So we'll talk about factoring those. We'll talk about what we do if there's a number out front. And then we're going to talk about something called quadratic forms. So they factor the same way as these ones, but they look a little bit different. So let's first start by taking a look at why it's important to know this. So we've talked about factoring polynomials in the past. If you haven't checked out any of those other videos, you're going to want to if you don't remember. But first, we want to take out a greatest common factor, which means it's the factor that goes into all the pieces. If there is one, we want to take it out, regardless of what we're practicing. Second, we want to count how many pieces there are. Depending on what we're doing, we're going to look at those different terms. So if there are two terms, meaning two pieces there, we're going to use special products. So this is something like our difference of squares, our sum and difference of cubes, and another word for the sum and difference of cubes, those are the ones that you end up using our SOAP acronym for, right? So things like that can be used to factor. Anytime we have three terms, those are called trinomials, we're going to use what's called the X games or the X method. That's a common way of organizing how we factor those out. And four terms is grouping. Now, the key thing here that sometimes people forget is they forget that greatest common factor. They also forget to factor completely. So what we're going to be looking at is we're going to run into situations where we factored it, but there's actually more factoring that can be done, and we want to make sure we factor it all the way. So let's go ahead and take a look at these first few. So looking at this first one here, I want to factor this. So the way that we factor something with three pieces using our X games is we want to start by drawing our X. Now we always multiply to the last number. So we want to multiply to 27. And we want to add to the number in the middle. We're going to take the sign with it. So we want to add to negative 12. Now, if you're good at your multiplication facts, awesome. If you're not, multiplication table can be a fantastic resource. So if you have one and you haven't already gotten it out, you might want to get it out just so that you have that resource. So what we want to do is we want to look for numbers that multiply to 27 but add to negative 12. So when I start thinking of factors of 27 or numbers that multiply to that, you can get things like 1 and 27 and 3 and 9. Notice how we only have whole factors here. That's what we're shooting for. So as we look at those, in order for me to get a negative 12, I would need a negative 3 and a negative 9. So this would then factor out into being x minus 3 and x minus 9. Notice how the negative signs that came from these two numbers come straight over into our factoring. So it's like an x negative 3, x negative 9. Same idea. So let's take a look at this next one here. So do you see how there's that 2 out front? Well, anytime we factor, we want to take out a greatest common factor if there is one. So we want to see, is there a factor that goes into 2, negative 16, and negative 40? Yes, the answer is 2. So we can factor out a 2 here, and we get x squared minus 8x minus 20. So then from there, we want to set up our X games and factor. So I'm going to multiply to the end number, add to the one in the middle. So I want to find two numbers that multiply to negative 20, but add to negative 8. So what numbers multiply to negative 20 and add to negative 8? Well, let's just look at what numbers multiply to 20. We get 1 and 20. We get 2 and 10. We get 4 and 5. Now, when this is negative right here, what that means is we want the difference between the factors to be whatever's down below. When it's positive, we want the sum of the factors. So 3 plus 9 is 12, which is why we use 3 and 9 on the first example. On the second example here, we want to figure out which ones are 8 apart because it's negative. So that 10 and 2 are the ones that are 8 apart from each other. So that's what we're going to end up using here, our 2 and our 10. Because we have negative 8 left, our 10, which has more negatives, is going to be the one we want. So you can always double check that in your calculator. 2 plus negative 10 should give you negative 8. So then we can write out our factored pair here. Don't forget your 2 as being 2 times x plus 2 times x minus 10. Now, the order of these two things here don't actually matter. You can write 2x minus 10, x plus 2. It doesn't matter, just like how 3 times 4 is the same thing as 4 times 3. That's called the commutative property, meaning you can rearrange the order and still get the same value. It works for multiplication, so don't worry about it. So we want to go ahead and take a look at these other examples here. You are welcome to pause it and try this next one on your own. When you feel like you've had enough time, unpause the video and we can go over it together. Sweet. Hopefully you've had enough time to try this one on your own. As we go over it, make sure you are checking your work here. So we should multiply to 16, add to 10. What numbers multiply to 16 but add to 10? That's right. It's going to be 2 and 8. So we're going to factor this into x plus 2 and x plus 8. And as a reminder here, this is exactly the same thing as x plus 8 and x plus 2. So we shouldn't have to worry about it. Now, I think we've kind of gone over enough of these. If you wanted to try another one here, you totally could. This one would multiply to 12. We want to add to negative 8. What numbers do that? Well, we are going to end up with a negative 6 and a negative 2 here. So x minus 6 and x minus 2. So there are lots of examples of how we can do these. So that's how you do the most basic one. But then we've got to ask ourselves, what do you do when there's a number out front? Well, in that one example, we were just able to factor it out. So let's take a look at this one. 4x squared plus 13x plus 3. Shoot. The greatest common factor here is 1. I can't factor out that 4. So what do? So if there's a number out front, but you can't factor it out, what you need to do is do the first number times the last number. What it allows us to do is it allows us to get a little bit of a bigger quantity when it comes to multiplying. So now what we want to do is we're going to multiply to our first times last, which is 12. Then we're going to add to the number in the middle, just like we always do. So add to 13. So what numbers multiply to 12 and add to 13? Well, this is what a lot of people forget, but don't forget about 1 in the number. So in this case, we're going to get 1 and 12. But the answers 1 and 12 are 4 times bigger than what they should be because we had to multiply by that 4 out front in order to factor it. So to make sure that we have the right size, what we're going to end up doing is we're going to end up dividing both of these answers by whatever we multiplied by. So I'm going to divide them both by 4. Now, 1 divided by 4 is 1/4. We want to simplify a fraction if we can, but if it doesn't divide, don't change it to a decimal. 12 divided by 4, on the other hand, equals 3. So as we go to write this, we're going to write x plus 3. And I know your first instinct is to write x plus 1/4. But remember, when we factor, we're doing the opposite of multiplication. So if I go to remultiply this back out, it should equal what I started with, right? But if I do x times x, I get x squared. And I want 4x squared. So instead of writing x plus 1/4, what we actually do is it's called bottoms out. You're going to take the bottom number and write it first. 4x and then plus 1. So now all of a sudden, when we go to do that multiplication there, and we're looking at multiplying 3 times 4x, we get a 4x squared. Now, the easiest way to check it is to try the first two numbers and try the last two numbers. What's 3 times 1? 3. So because those last two, that last number and that first number match up, we know that we factored this correctly here. Let's take a look at this next one. It's going to be the same. So we've got our 3, our 2, our -7. Is there a common factor between 3, -7, and 2? No. So then what we need to do here is factor it. So we're going to do the first times the last, and 3 times 2 is 6. So we're going to multiply to 6. We're going to add to -7. Just like on our last one here, we're going to have a cute combo of 1 and 6. They're both going to be negative here because our 7 is negative. But then because we multiplied by 3 to begin with right here, we need to divide both of these by 3. So -1 divided by 3 is just -1 divided by 3. -6 divided by 3 is -2. So we're going to write our x minus 2, and then we're going to take the bottom number and kick it out to write a 3x minus 1. Okay, we'll do one more example all together, and then I want you to try the next one on your own. So again, we look for our greatest common factor. 2, -5, -7 doesn't have one. So then we want to multiply our first times our last, and we multiply to get -14. Then we want to add to the number in the middle, which is a -5. So then we start racking our brains. What numbers multiply to -14 but add to -5? Because it's a -14, we want two numbers that have a difference of 5. And that's going to be 7 and 2. So we've got 7, we've got 2. Now, because it's a -5, our bigger number needs to be negative. So we're going to have a -7 over and a 2. But because we multiplied by 2, what do we have to do? We're going to have to divide them both by 2. So divide by 2, divide by 2. -7 over 2 doesn't simplify, but 2 over 2 simplifies to 1. So as we go to write our answer, we're going to kick that bottom number out to the front, and we get 2x minus 7 and an x plus 1. So what I want you guys to do is try this next example on your own. So we'll take a moment to pause the video, let you try it out. After you've finished, or most of you have finished, unpause the video and go ahead and check with me. Sweet. Hopefully you've had the chance to go over this video. So what we want to do is we're going to take our first times our last. We're going to multiply to -20. We want to add to 8. So then you're sitting there racking your brain trying to think of what numbers multiply to 20 but have a difference of 8. And you're right, that's going to be 10 and 2. Because we want our final answer to be positive, our bigger number needs to be positive. So we're going to end up with a negative here. Now this question is a little bit weird, and I need you to go with me on it. What we have to do is then divide both of these by 4. Okay, we divide them both by 4. Now we need to check to see if these fractions simplify. Does 10 over 4 simplify? Yes. It doesn't simplify into a whole number, but it simplifies into 5 over 2. Does -2 over 4 simplify? Yes, into -1 over 2. So in this case, we're going to kick those bottoms out on both questions. We're going to end up getting a 2x plus 5 and a 2x minus 1. Now, if you're like, oh, did I get that right? Don't forget that trick where you can do the first times the first to get a 4x squared, and the last times the last to get a -5. And because those numbers match up with what we had up above, we know that we've done that one correctly there. So that's how we can factor when there's those values in front. Now, we're going to take a look at these next questions here. What do you notice? They're still trinomials. They still have 3 pieces. However, all of a sudden our exponents have changed. They're no longer x squareds, but they do have something very specific in common. Notice how this one is a power of 6 and this is a power of 3. The one in the middle is half of the first one. The same thing happens here, a 4 and a 2, right? Half of the other one. All of these ones here, a 4, 2, an 8, 4. This 8, 5, 2 is kind of a weird one, but we'll take a look at it, right? So what happens is whenever you factor a quadratic, in order for us to use the exponents to factor it, the exponent on the first piece needs to be double the exponent on the second one, or the second one has to be half of the first one. So all of these quadratics that we've done here have been a power of 2 and a power of 1, power of 2, power of 1. So we can use the exact same process that we were doing before to factor these ones with a higher power because they're in what's called quadratic form. So the first one is double the exponent of the second one. So the way that we would end up doing this one is we would factor it just like we always would. So we're going to multiply to the last number, add to the one in the middle. So I'm going to multiply to -6. I want to add to 5. So what number is multiplied to -6 but add to 5? Now this is a tricky one. A lot of people will think 2 and 3, but we want to get a -6, right? And if I do a -2 and a -3, it's not going to give me a +5. But if I do a +2 and a negative, or a +3 and then +2, it's not going to give me a -6. So the pair here that we end up using is actually going to be a 6 and a -1. Interesting, right? Now, when we go to write out our factored pairs here, instead of just writing x plus 6 and x minus 1 like we usually do, that x times x will only give us x squared, but we want an x to the 6th. So what we write here is half of this exponent. So what is 6 divided by 3? Or 6 divided by 2? Exactly, 3. So we actually have an x to the 3rd plus 6 and an x to the 3rd minus 1. Right? So we are able to break these down just like this. Now, the cool thing about this is we can keep going if we wanted to. So do you see how these exponents are no longer 1s? They're 3s. So now we can see, do I have a difference of cubes here with these? And guess what? We do. X to the power of 3 is x, x, and x. X to the power of 1 is 1, 1, and 1. So we can actually write this one as being x to the 3rd plus 6 times x, 1, x squared, 1x1, and we can go through our SOAP acronym. So same, opposite, always positive. And this is going to be our fully factored form there. Pretty cool, right? We can split it all the way up. So let's take a look at this next one all together. We'll move this little equation there. Let's take a look at our next one all together. So we want to factor this. It's got 3 pieces. This one is double this one, so we know we can use the x games. So we're going to multiply to 49. We're going to add to negative 14. So what numbers multiply to 49 but add to negative 14? Well, the numbers that multiply to 49 are 1 and 49 or 7 and 7. So this will actually end up being a negative 7 and a negative 7. Now, when I go to write my answers, I'm not going to write x minus 7, but I'm going to do whatever matches with that middle because it's going to be half. And we're going to get an x squared minus 7 and an x squared minus 7. Now, once we get to this point, we want to check, can I factor it anymore? Just like we were able to factor this one down here. Now, what we want to look for is, can we? Well, in order for us to factor using these where they're squares, the second number also has to be a square. So is 7 a perfect square number, or what number times itself gives us 7 that's nice? Not really. So we could split it up with square roots of 7 if we wanted to, but we're not going to. So this one actually stays factored right there. Okay, let's take a look at another one of these so that we can kind of see how this process works. Again, so we've got a power of 4, a power of 2. Because the second one is half of the first, we can use our x games. So we want 2 numbers that multiply to 1, but add to negative 2. So what's that going to be? Negative 1 and negative 1. So we can go and write this. Instead of it being x, we're going to get an x squared minus 1 and an x squared minus 1. Now, whenever I get to this point, I have to ask myself, can I factor more? Right? Can I factor this more? Now, is x squared a perfect square? Yes. How do I get x squared? I do x times x. Is 1 a perfect square? Yes, it's going to be 1 and 1. So I can actually factor this one. Because our second one is the same, that one also factors. Now, because it's a negative, we're going to have a positive and a negative on both of these. So this one actually factors out into x plus 1, x minus 1, x plus 1, x minus 1. Right? So we broke it all the way down from there. And this one is as factored as it gets. Now, some people will actually write this using exponents. So you could also write this as an x plus 1 squared and an x minus 1 squared if you wanted to. I don't know if that's any simpler than the one up above in the box, but you can do it that way. So knowing that, this fourth problem here works exactly the same way. So what I want you guys to do is I want you to try this one on your own. So we're going to pause the video just like we did before. Take a couple of minutes to try factoring this one. Don't work by yourself. Work with a friend. After you have finished getting this as factored as you feel like you need to, go ahead and unpause the video and check your work along with me. Okay, hopefully you've had the chance to finish factoring this one on your own there. So let's go ahead and do this. 2 numbers that multiply to 16 that add to negative 8, that's going to be negative 4 and negative 4. So I'm getting an x to the half of that, 4 minus 4, and an x to the 4 minus 4. So now I want to know, can I factor this anymore? Well, is it a difference of squares or a difference of cubes? Well, this one is a difference of squares. How do I get x to the 4th? Well, I can do x squared and x squared. And how do I get a 4? I can do a 2 and a 2. So I've got an x squared again, a 2 and a 2. These are going to be opposite signs. So we end up getting x squared plus 2, an x squared minus 2, an x squared plus 2, and an x squared minus 2. Now, could we continue trying to factor this? I guess if you wanted to. And is there another way that we could write it? Yes. But do we need to check to see if these factors anymore? Definitely. So is x squared a perfect square? Yes. But because of this plus, we can't factor this one. So we know that this is going to be part of our final answer there. Our x squared minus 2. Well, that minus tells us it could be a difference of squares. X squared is x and x. But in order for me to get a 2, I'd have to use square roots of 2s. And that's kind of gross. So I think we're good to leave it there. Now we can check along with these other ones that x squared plus 2 is the same as before. So is our x squared minus 2. So we can leave our answer in this form or in this form. It doesn't matter, but both of those are factored completely. So you can kind of see how those work. Now, the very last thing that we're going to touch on here is we are going to touch on what happens when it looks like this. Now, as you notice, this 8 and this 5 are not the same power. So can I factor this? Well, what's our very first step anytime we factor? Before we do anything else, very first, we're supposed to check for greatest common factor. So let's look. Is there a number that goes into 3, 15, and 18? Yes, it's a 3. And can I take out any of my p's? Definitely, we can take out 2 of them. So all of a sudden, I'm going to take out a 3p2, and I'm going to be left with p to the 6th plus 5p3 plus 6. Now, as we look in this piece here, we have a trinomial. So we want to see if we can factor that trinomial. Well, this power of 6 is double the power of 3, so we can factor it using our x games. So our second step is, because we have that, we can use our little x games here. So what are 2 numbers that multiply to 6 but add to 5? Well, we are going to get 2 and 3. So we can write this as 3p squared, because we don't want to forget this piece from the beginning, times p to the 3rd, because that's our middle exponent there, plus 2, and p to the 3rd plus 3. Now we want to double check to make sure these last 2 don't factor. So p to the 3rd is a perfect cube. It's p times p times p, but 2 is not a perfect cube. So we know this one is good. This one doesn't really factor. You could write it as 3 times p if you wanted, but that's not really any simpler. Our last one here has that same problem. The p to the 3rd is a perfect cube, but that 3 is not. So this right here is actually going to be our completely factored form. So that's how we can factor polynomials in quadratic form. If you have any questions, don't hesitate to ask, but that is how you can factor trinomials, right? Basic ones, so those ones that we started with that look kind of like this. When we have a number out front, we just do that first times last. And then when they have a higher degree, you want to factor out a greatest common factor. And once you do, if the first one is double the second one, you can factor it using the x games.